So good morning to all of you. So today we'll go for different types of ubiquitous communication. So in unit number 6, we have finished personal, then second one is audio, video, then data networks, voice networks. So next point is your ubiquitous network. So what are the different types of ubiquitous network? So first one is a wireless network. Second one is a power line communication, that is your PIC. Third one is personal area network. Fourth one is a body area network, and last one is a mobile user network. So these are the examples or the types of ubiquitous network. So first one is a power line communication, that is your PLC. That is power line communication. So power line communication is an alternative way to ubiquitously access data and audio video content. So we can access audio video contents using this PLC. So power line connection conducts electricity to deliver energy that can be modulate electricity as a signal and be used as a channel to communicate data and audio video contents. PLC describes, that is a power line communication describes a range of systems for using electricity distribution wires for simultaneous distribution of data. The carrier can communicate voice and data by superimposing a modulating signal over the standard 50 to 60 Hertz alternative current, that is your AC current. This can be used in home automation for remote control of lighting and appliances without the installation of additional control wiring. So example is your X10 and the home plug power line alliance. So these are the examples of your PLC. Then second one is a personal area networks. So wireless personal area networks, that is a WPAN, have been specified by IEEE PH02.15 standards working group. A personal area network is normally confined to the person or the objects that typically extends up to 10 meters in all directions and envelopes two or more objects or a person, whether stationary or in a motion, whether he is in a standalone or he is in a moving state. The WLAN standards was initially considered for the extension but was dropped because of its high power requirement and its higher network management overhead. So more overhead are required in these personal area networks. Bluetooth, Zigbee, and I are the example of systems that can use to implement the personal area network. Typical application include multi-network phone depending on network access, that is intercom, cordless phone, and cell phone. Mobile internet access on the move. Interactive local conferencing to instantly exchange the information. Hands-free headset to communicate and control. And last one is automatic synchronization of information for the mobile user. Then the third one is a body area network. So body area networks, it consists of a set of mobiles and compact intercommunicating sensors that are either wearable or implanted into the human body. A typical body area network application can monitor vital body parameters and movements, such as examples are the monitor your ECG, EEG, and EMG signals. ECG used in a medical field. Then third one is a data management, either to store them in some device on the body or later we can upload and analyze. The periodically transmit data in real time via some external network interface. So we can get the data real time, or we can store that and then we can transfer or upload that data. Then next type of networks in ubiquitous is mobile user network. So not all networks accessed by mobile users, application and devices need to be via wireless networks and vice versa. Wireless access devices can be static and mobile users can move in between wired or wireless hotspots such as an internet cafe. Mobility refers to the mobile application in which users are free to continuously move anywhere within the range of wireless network. Portability refers to the mobile device that is stopped or suspended during the roaming itself but attached at discrete access point intermediately. This is useful for mobile office type scenarios when users work at mobile multiple locations. So we can go for the roaming is the best example. Example at central business premises, at customer premises, and at home. Whenever the customer is working in these three different locations, so he can actually connect to that network or area. So it is a mobile user network. Then service-oriented networks, different application services were coupled to the specific network because different application needs different levels of support for data transmission function such as latency, sequencing, performance, and reliability, channel sharing, data controls, and security. It is a simpler to design networks to support one specific set of application requirements rather than support multiple applications that have different messaging requirements because this may conflict the user. Nowadays, services are oriented to be coupled less to specific network and to be available across heterogeneous networks. So based on the service, which type of service we are using. So user can not depend on the specific network. He can go for the heterogeneous network. So based on the service oriented, so to use the service, user must subscribe to the particular network and service configuration on that network. For example, voice call via telephone networks and audio video contents via audio video wireless broadcast network. So two different. Here we can go for any one based on the user's requirement. Then paradigm shift from network oriented to service oriented architecture. So this is a network oriented user and service oriented to the network, and service oriented network oriented to service. And so here are different types of networks. So service oriented and network oriented. So network oriented users and services. So here are the services. So network has the services and have the subscriber or your telephone. So here what happens? Service oriented users are there, they have the services and have the network. So this is opposite to your network oriented. So based on the services, it is called as a service oriented, and this is a network oriented. So we are specifying the networks, and here user specifies the services. Service orientation in edge network, a simple abstraction of network topology to support universality is to partition a communication network into two parts. So first one is an access network or the edge network, and second one is a core networks. Access networks is a network that uses and users and application use to access the network. Core network comprises the interlinked networks that then link to the access network. Important design decision is whether or not to put a complexity or intelligence for service specific communication into the core network. So example is your PSTN, public switching telephone network, or in the edge network, or in the both. So in the both we are going for the IP networks. Then there are arguments for end-to-end or edge-based complexity is to keep the core network relatively simple to optimize the core networks only to forward the root data packet. The main argument is that functions placed at low level of system may be redundant or of little value when compared with the cost of providing them at the low level. This implies that the simple and as a neutral as possible network should be used. Then next type of network is a content-based networks. A content-based networks is a communication infrastructure in which the flow of message to the network is driven by the content of the message. So what type of content you want to send rather than by linking specific sender to the specific user. With this communication pattern, Receivers subscribe to the types of contents that are of interest of them without regards to any specific source. Senders simply publish information without addressing it to any specific destination. In a content-based network, nodes are not assigned unique network addresses. Data is not addressed to any specific node or node group. Instead, each node advertises a receiver predicates or a are predicates that defines data of interest for that node intends to receive. Then programmable networks. Typically, service providers do not have access to the routers. The routers control environmental algorithms and route states in order to optimize the network use of different applications. This makes the deployment of new network services, which could be far more flexible than proprietary control systems, impossible due to closed nature of the network nodes. Programmable networks allow some of the network elements to be reprogrammed dynamically by injecting executable codes that could support application-specific services into the network elements such as routers and switches. What are the drawbacks of programmable networks? Complexity increases and there is an increasing risk of instability and more malicious code to take control of core network element. Two main initiatives to establish programmable networks. First one is your REPA active networks, that is AN program, and second one is open signaling, open sign communities. Community. Open sign approach seeks to establish open programmable network interface, and AN, that is a active networks approach, is to support injecting executable code into the network element to reprogram that code. Then overlay networks is a virtual networks built on the top of physical networks that provides virtual infrastructure to one or more application. It handles the forwarding and handling of application data in the way that can be different from or in computation with basic underlying physical networks such as the internet or PSTN. It can be operated in the organized and coherent way by third parties, which may include collection of end users. So we'll stop here.